A uranium element with A is equal to 235 splits into two atoms, with one of them being zirconium with A is equal to 91. What is the identity of the other atom? So I asked this question in my session, and not many people got it right. It is an advanced question, but the concepts that it tests you on are what you learn in lecture. So to try to break down this question, first of all, what is A? A is your mass number. A is something that we see in isotope format, so it wouldn't be Z, it would be Z. So, for example, we see something like this. All A is your mass number. Your mass number is just the number of nucleons, which is anything in the nucleus. We know that in our current understanding of the model, we have neutrons and protons in the center called the nucleus, and around them are electrons that are floating. So when we're just talking about the nucleus, we're going to be focusing on the neutrons plus the protons. That is your mass number. Now your Z is going to be your atomic number. Your atomic number is basically what is on top of every element on the periodic table. It's just the number of protons. The key thing to understand here is that the number of protons is what dictates what element you have, right? Because we know that different atoms, or we know that the same atom can have different number of neutrons and different number of electrons. So isotopes, which is, this whole thing is called isotope format. Isotopes just mean the same element, but with different number of neutrons. So an example of this one would be, I think, neon. It has isotopes of neon 20, neon 21, neon 22. So we know that the same element can have different number of neutrons. So this doesn't really tell us anything when we want to find out what the other atom is. Now, what about electrons? Well, we know cations and anions exist, right? For example, when fluorine goes to fluorine minus, this is an anion because it gained an electron, but it's still fluorine. Or when lithium goes to lithium plus, right, it lost an electron, it became a cation, but it's still lithium. So we know that the same element can have different number of electrons. So electrons tell us nothing about the identity of the element. The last thing that's left is the number of protons. Now, if you look at your periodic table, since the number of protons is directly above the element, there's not any two elements that have the same number of protons, right? The number of protons is unique to every type of element, right? It's just very unique to it. So we know that when we are concerned with the type of element or what element we have to look at the number of protons. So let's try to break this down in terms of protons. Uranium, they told us, has A is equal to 235. A is just your mass number. It's neutrons plus protons. Again, doesn't really tell us much. We only want the protons. So if we just look at our periodic table, we see that uranium only has one number of protons, which is 92. All right. So cool. We broke it down, right? And we know that we got X and Y, elements X and Y, just for the sake of explanation, right? So this is Z, and somehow they have to equal a total number of 235 for mass number or a total number of 92 protons, right? They already gave us one of these. They told us zirconium, right? So zirconium, and they also gave us A. Like I said, I'm not really concerned with A, but since we know the identity of the element, we can also find out the number of protons it has. So if you try to find zirconium on your periodic table, zirconium is in period 5 and group 4. And I see that the atomic number on top of zirconium is 40. So I can replace Z with 40. Now we have an equation we can work with, right? We can solve for A because we can just focus on this one, these three, and make an equation with that. But like I said, A doesn't really tell us much. The main thing to focus on is the number of protons. So I'm going to just focus on 92, Z, and 40. So we know that 92 protons split up into Z plus 40. So all you have to do here is subtract 92, or subtract 40 from 92 to get that 52 is equal to Z. So the number of protons for X is equal to 52. Now, I don't really need the mass number because 52 is only going to correspond to one element on the periodic table. So if you take a look at your periodic table, the answer is TE. This is in it's in period 5 and group 16. So yeah, TE. And so because of that, C is your answer.